Welcome to the Artificial Intelligence Podcast with your host, Dr. Tony Huang. Today, I'm with a special guest, Michael. Can you introduce yourself?
Hi, I'm Dr. Michael Wu. I am the Chief AI Strategist at a company called Pros. And yeah, I do a lot of interdisciplinary works across different departments of Pros, but they're all AI related.
You have an academic background. How was your transition from academic research to applied AI in industry really shape your view on where the field is headed towards?
Yeah, so my PhD was actually in computational neuroscience, where I use essentially any physical science modeling techniques, anything from statistics, convolutional neural network, or any of that sort of techniques to model the visual processing within the human brain. And we primarily focus on the primary visual area, and we go up all the way up to visual area 4, where the attention mechanism start to kick in. And it's so that's where my research was. And then jumping to the industry, it was a little bit, I would say, a little bit of an accident as well, because I was actually not looking to join the industry. I was actually wanted to look for a confirmation that the industry was actually not right for me and go back to academia. And then it turned out that at that time, one of my friends was the CEO and founder of a social media company. And he basically offered me the freedom and autonomy to be a real scientist doing research, even though I'm in the industry and not in academia. So then, and yeah, so that was what brought me over. But I was doing not so much my work, the nature of my work is not, I would say, changed dramatically, because I still use statistical methods, fitting models, and building probabilistic model, engineering features, and all that stuff that any data scientist would do. But it's on a very different type of data, right? In the research I was doing physiological recordings from brain, from fMRI data, and also physiology data. So the data and the domain is very different. But after I get in the industry, is social media data, and it's conversational, and that was quite a, I would say, a switch from the kind of computational neuroscience to social media, because I actually literally know nothing about social media. And so that was a bit difficult, but I learned it. And then there was another switch. I was there for about 10 years, actually exactly 10 years, thinking back. And then was wanted to also, again, didn't actually was actively looking for a job, and was wanted to take a rest because it's been 10 years of doing all this stuff. And then so I was at that time I was like doing a lot of work with academic institution like UC Berkeley and various. So I have lecture affiliate honorary positions in a few universities. And then pros actually reach out, and then that kind of spurred me to look a little bit deeper into this company. And I find it quite interesting that they also have a lot of these very academic level research in operations research. And yeah, so that's what attracted me to pros. And again, at that time, I basically was still doing a lot of machine learning training of models. And but then switching to pros was a little bit of change in role, because I was more senior then. I started up in the social media company and back then it was so far back, I think the term data scientist was not even a term. I started out they call me an analytics engineer, and subsequently I become data scientist, and then principal data scientist and chief scientist of that social media company. But then when I joined Pros, I also did not have the domain background either. I remember very vividly the CTO at that time interviewed me, and I said, "What do you think I can contribute to Pros? Because I have no background in pricing and revenue management. And I don't know anything about any of the industry that Pros serve." And at that time, he gave me a really interesting answer. He said, "Actually, that's why we wanted you to join us, because you would enable us to look at some of these problems without the kind of the industry baggage, the heritage, and be able to solve it in a really fresh and new kind of perspective." right? So I thought, oh, that's rather interesting. And that's the rest of it was history. Yeah.
Very cool. Yeah, I think you and I have like the same background. I had my doctorate in computational biophysics. So
Hmm.
I did a lot
Yeah.
of quantum mechanics, molecular dynamics simulations before hanging out the industry. Like I headed out the industry like right away. But I found like the biggest difference between academic research and like industry was just like the tools that they use. Like I remember in like academia, my advisors would use like Fortran and
Mhm.
nobody
Yeah.
other
Yeah.
than academia uses Fortran, right? So it's like you use like C or Python in industry, but that was like the biggest like difference I saw. And then obviously I had to upskill when I had started off. But like in your opinion, what's like the biggest gap that you saw between AI research and real world implementation?
I think it flipped around. I early on, I think the academia was, I would say, a lot more rigorous. There, I think in the industry, when you do research, it's very problem domain specific and it's not, I would say, general and not as generic and applicable everywhere. And re academia tend to like to solve problems that are very generic or very general, right? So you solve one problem, you solve it for hundreds and thousands of use cases, right? Whereas in the industry, you have a customer base, right? You're trying to meet the needs of your customers. So they tend to be, I would say, maybe not as rigorous is probably the wrong word, but more specific to the industry use case. As a result, it ended up obviously not as general, right? So it feels like you're cutting corner or something because that's a harder problem to solve it for the general case. We all know. But I think now it's in the AI industry is almost, I would say, switch around. The industry is actually doing really cutting edge research in this Gen AI and also the path towards AGI and artificial superintelligence as well, right? They're tackling something that's super, I would say, generic, right? And that's the AI basically knows everything and anything and everything out there. So I think that's rather interesting to me.
And then in your opinion, which like emerging AI architecture do you think is underrated or overhyped right now? I can go first. Like I think LangChain is overhyped. I don't think anyone should be using LangChain because it's just if anyone has ever used LangChain in production, that thing breaks down so fast. And like the federal government uses like LangFlow, which is like this drag interface for LangChain, and that
Yeah,
thing has like a ton of security vulnerabilities on there. So I still don't get why people continue to use LangChain. I understand like it's really easy to get up and running,
yeah,
but
it's easy.
yeah,
Yeah,
it's easy, but it's not like production grade, and people are moving that into production. So
yeah.
I try to advise them not to like do that and just keep it in like POC or discovery phase only.
Yeah, so I
But
think
like,
you
yeah,
certainly don't want to write production level kind of code with that. I think, but the thing, as you said before, the advantage that LangFlow and LangChain has is actually very easy, right? People who have no, I would say, coding or STEM background, they could just pick up LangFlow and just connect this GUI, right? Connect the data flow and tell them what you want to do. And then you have it. You could build an agent, right, in the afternoon or something like that, right? And a lot of these and in fact, pros, we actually do use it, but internally. So basically, the once the environment is actually secure in the internal kind of setting, we do have product managers who are not necessarily coders and engineers or data scientists, right? Even our HR team or departments that are not technical, right? Not traditionally technical at all, right? They were able to use this to build tools to help them make their work more efficient, right? So this is kind of the more internal transformation side of my role. I mean, my role as a chief AI strategist is actually, as I said before, it's quite cross-departmental between the researchers in the AI research team and the product team, and there's also an external component to that. So I think there is some use case for them, but you probably don't want to write kind of production level code. You probably want to have some translation, but then you could get an agent to do codegen, right? To use this base and write it into Python or something like that. Or if you want, they're just not, it doesn't do very well with C yet. I think there's just not as many training data out there. But yeah, if you want something in Python, you could definitely do that very well.
and then what are you seeing right now with like just AI agents in general? It seems like every vendor is like spinning up their own offerings around like their own way that they put together like AI agents.
Yeah,
What's the current like like landscape look like?
Yeah, I think in the industry, certainly a lot of company are experimenting with agent, right? And then I think besides probably everyone in the company, I think it's encouraged, right, to experiment and try to do something, right? But within the product stack, right, certainly we will not use Langflow for those. I probably use something else. And they are building something, right? They're building MCPs, experimenting how to transform their traditional AI tools into essentially tools that these language model is able to call and use. And you do that essentially through MCP to actually let the language model understand what does this tool do, right? And what does it do? How do you call it? What's the proper API and what input does it need, what format does it need, and what's the return, what's the output, and so that it knows a little bit about what each tool does. And when you ask the language model to solve a problem, it can make the proper call to these tools that already existed in a lot of the enterprise. Yeah.
And then you said the word MCP, like I know what it is.
Mhm.
It's model
Oh
control
yeah,
protocol, but can you like describe what that is to like in layman's terms to our
sure.
listeners who don't know?
Yeah, the best way I think to describe this is almost think of it as a universal media hub, right? I mean, if your language model is like your laptop or your computer, right? There a drawback in this language model, whether it's the large language model, these large reasoning model, they could reason and think. They are very smart, right? But they're all what we call passive, in a sense that they can tell you a lot. Even if you ask a really difficult problem, it will actually tell you how to solve it. Even to the extent that if you ask it to, I actually tried this. I was looking for a table and then I found a table, a very simple table that I said, it looks like this is so simple that I could build it. And I took a picture of it, leveraging the multimodality capability of this language model, right? And say, how do you build this table? You could even tell me detail, like what tools I need and how to cut the different pieces, how to assemble them together, and how to even paint them, and then construct them to this very simple table that, at the end, right? So it could tell you a lot of things in excruciating detail, but it cannot take any of those action, right? At the end of the day, you don't have a table. You still need to follow those actions and take those actions yourself, right? So you could think of the language model as passive being that way. It cannot take action. It's passive. It's not active, right? So in that respect, right, there's how do you turn these passive machines, right, that are intelligent, super intelligent, in fact, right, able to solve PhD level problem and coding problem, math problem, and all that, and turn them into essentially a tool that can actually take action. And basically, these are this is through the use of tools, right? So if you're in the case of building a table, right, you could imagine that in the future, probably there's something out there today already, right? You could learn how to call an API that controls maybe a robotic arm, right? That actually it's able to use actual tools to cut the woods and then assemble them, right? And that's all done through API, right? Maybe it's you just tell them like grab this tool and maybe at this coordinate, and then, so depending on how low level the programming language the robotic arm is, right? So you can actually, so this tool usage, right, is essentially what enables the language model to take action, right? And MCP essentially is, think of it as I said, like a media hub, right? There are a lot of things that the computer can do, but it needs to connect to the the media hub to display this on a projector or something like that. There are a lot of things it can do, right? So this MCP is, think of it as almost this translation layer between the language model and all these tools that can help the language model take various different actions.
And like in your opinion, like how do you see the relationship between large language models and like more specialized AI systems like evolving in the future?
I think they will work together, right? I think so the reality is that there are lots and lots of tools that already have been developed. These are AI tools, these are more, I would say, they're not the generative AI typically, right? They're more, I would say, the numerical AI, right? Where the input is usually some kind of a data set, a large data set of some sort, and then they do some analysis on it, right? And it produces some numerical output, right, to drive some action. And you can, because these systems can actually learn from feedback data stream and actually change the model, right? So they can also take action to automate some tasks. So I use this as a criteria to define AI, right? If some kind of tools that can automate human decisions and action, they're good enough to be at that human level to automate human decision and action, and is able to learn, and learning means they're able to improve their performance with usage. The more you use it, the better it's able to perform what it's supposed to do. So, and if you meet those two criteria, it's basically an AI. So, and there's lots and lots of, I would say, algorithms, right, that were developed. There are essentially AI tools, right? And these are, like I said, these are not generative AI. I call them numerical AI or analytic AI or prescriptive AI. There's lots of names out there because AI actually has been around for a long time, since the 1950s, I think. Yeah, so lots of different types of AI. I think in the future is that like these language model, which is very generic, right, is able to solve a lot of variety of problem, but cannot take action on their own, will be able to call these tools, right, and use them as a tool to help them either ground them, they answer their response, or execute some kind of actions, right? So I think they will work together extremely well, yeah, in the future.
And then looking forward in the future, what are like some technical hurdles do you think we're like underestimating on the path to like general or like artificial general intelligence or like AGI? For me, I think it's our big issue is like the transformer model that all of the Gen AI solutions are built upon. Like they scale, like they require like a quadratic relationship, like
Yeah.
a VRAM from like the
Mhm.
GPUs that we use in order to power these systems. And so we really got to get away from using like the transformer models, which have gotten us very far, to a different type of model in order to achieve it. So maybe like right now, I'm reading up on some papers, but they're trying to convert like the quadratic relationship into the linear relationship. So like
Yeah.
if it scales linearly, then
Yeah,
you
it's better.
could
Yeah.
run like a very large model on a very small GPU, which will
Mhm.
help accelerate AGI. But in your opinion, what do you think is like a big technical hurdle that we're not thinking of?
I think the Yeah, I think the hurdle is probably not a technical hurdle in its nature. It's probably more of a human adoption, societal acceptance hurdle. I think there are some technical challenges, but I think those will be overcome over time. I think the bigger problem is, can society or government or accept and embrace this technology, right? Or are they going to just keep it in a box and not let it loose? And that would be a pity, right? And in that respect, I think the AI ethics is really important, right? Because now when you get to these agents, right, they can start to take action, right? Which means when you take actions in the real world, whether it's like making a transaction, right, these are taking actions digitally, right, or in the physical world, right, you can actually change and impact a lot of things very dramatically. Unlike the language model or the large reasoning model, they're, yeah, no matter how smart they are, they're just telling you things, right? There's a limited amount of, I would say, damage or that you can actually do. But when you go into agents, then that's a different story, right? So I think as more and more people get into this area, right, where everybody's building the agents, then I think the hurdle is probably not going to be a technical one. I think there are already, I think, attempts essentially to use a dimensionality reduction, right, to compress this quadratic kind of explosion of memory, right, to make it more efficient. There's also, I would say, using, I think, attention, right, because some of the actual kind of human-like type of attention to not everything in the past. Let's say you have I don't know, a million token, right? Not everything is actually super relevant to what you actually the problem that you're trying to address right now, right? So your attention can actually help you select, what part of your memory is actually relevant for this particular task. So there's actually a lot of, I would say, techniques out there. I don't know which one will actually win, but I think some will come out, and I think even to the extent that, as you said, like the transformer architecture, the language-based kind of intelligence, it may not be the AI that will bring us to AGI or ASI. And there's a whole camp of researchers, actually vision researchers, and so people like Yann LeCun, and they actually believe that it's more of these vision type of model, because before you are able to speak, right? Think of a child, right? A baby, right? Before they learn to speak, right? They actually learn a lot about how the world operates. simply from interacting with the world, the physics of the world, and all in this environment, right? And then language comes in much later from a child development perspective, right? So there's a school of that actually believe that this new kind of world model is probably going to be vision based, and that will essentially bring us to these artificial general intelligence and maybe a artificial super intelligence as well. But yeah, that's a little bit of a wild speculation there.
So like I guess for like companies and enterprise out there, like how would they prepare organizationally and ethically for more capable AI systems?
There's, for one thing, right? Don't be afraid to experiment, right? In fact, so my company is actually encouraging everyone, right, to experiment using the Langflow, right? They're not like, I would say, super secure in that perspective. But once you, I would say, contain it within the kind of the enterprise environment, right? And you have good security protocols for employees and everything, right? Then it's okay to experiment with it, right? And it almost essentially create this fail-safe environment where people are not afraid to fail, because even if you fail, it's inside your company, right? You could just scrap this language, this instance of the language model, and just reboot it, reinstantiate it, right? And then you're okay, right? Then no data is leaked out to the public, nothing, right? So it's actually you're creating this fail-safe environment really help company's employee to embrace this experimental mentality, right? Because no one's gonna senior leaders can, I would say, encourage or even incentivize all they want, right? But if there's a risk that, oh, if I do something wrong, I'm gonna get fired, right? Then that fear will be a strong, I would say, hindrance for people to embrace this kind of experimental mindset, right? So I think that's one thing, right? Embrace this experimental mindset by creating this almost a fail-safe environment so people feel safe to experiment, right? And yeah, and then the other thing is definitely, I would say, have a uh, AI responsible AI framework. I actually work on this a little bit, develop a responsible. This actually it's called a layer. It's a layer AI responsibility framework. So it's spelled LAIL. So it's a layer, yeah, framework, and it essentially it's a framework that tells these AI developers and what to focus on in which stage of your development. And I mentioned this earlier before that because I think my work actually spans both industry and academia, and it's quite different in the kind of standard, right? That they're these two kind of world takes, right? Academia, again, right? They try to do the all-encompassing, right? Very comprehensive, very high standard. Sometimes not the most practical, right? Industry, on the other hand, because they have financial pressures, right? And they're sometimes they focus on things that are not as comprehensive. So unless it's something like a core to their profit, right? Core to their revenue, right? So if it's so very often these type of AI framework in terms of responsible AI framework, right? They're more of an add-on, right? They're not this is not part of their kind of core kind of product, right? So very often in the industry you cut a little corner, right? But then so this layer framework is essentially a way to achieve almost as high of a standard as academia, but they do so but not enforcing you need to focus on all these different components of the framework, right? There's only a few things you need to focus on, but on different stages, right? If there's some may not even be relevant to you, right? And and so what to focus on, what you need to focus on at different stages that would help these companies to I would say follow responsible AI development. Yeah.
And if people want to like learn more about this from you, what's the best way to contact you?
Yeah, you could look for me on LinkedIn, Michael Wu, and probably wanted to add pros there, or because Michael Wu is actually a very common name. So you'll probably find many other Michael Wu as well. Yeah.
And then based on your work with like customer data and behavioral algorithms, what like privacy and ethical considerations keep you up at night?
Yeah, so there's a lot. This is actually why I spent some time developing this AI layered AI responsibility framework layer, historical layer. And that's yeah, so because I think it's important as AI become more and more powerful and it's going to impact more and more of our life, it should be, I would say, we should be more intentional about it rather than thinking about it as an afterthought, right? I think today a lot of these AI developers think of it as an afterthought. They just tag them. Okay, all right, now it's yeah, we need to investors asking it for it, or the public is asking for it. People care about this, so we need to do this. But so the layer framework basically, maybe we could talk a little bit about that, right? I'll just give you a preview. Essentially, it's as a think of an onion, right? There's different layers of this onion, right? And at the beginning, when you're actually developing the AI, right? At the very beginning, you need to focus on what we call the core layer, right? And that's essentially the layer one. And these are the table stake requirements, right? And some of the table stake requirement is that it has to be lawful, right? And actually, if you actually have do any research on responsible AI framework, you probably will find many of them out there. Every kind of company probably has some version of it. And they use words that are, I would say, slightly different, but they basically mean the same thing, right? So when I say lawful, it basically means compliant, and it could be very specific as well, like anti-discriminatory, because there are most places have anti-discriminatory laws, right? So just have to obey the law, right? So lawful and respects privacy, protects your data, so data security. So all these are probably mean the same thing, just and maintains your privacy and safe, right? So it's not going to have catastrophic failure or there's a human override, is resilient and all that, right? So these are the core table stakes, right? And they're called the core table stakes because if you don't meet these requirements, probably no one's going to even use your AI. So right at the beginning, you have to just focus on these, right? And that means have strong data governance and all that data privacy practices, right? So all that just is the core, right? And then once you're able to meet the requirement of the core layer, right? Then the AI has to be responsible to the user of the AI, right? So that's layer two, and being responsible for the user. So the user of the AI, how the AI be responsible for them, right? Is again three things, right? They have to be competent at what it's doing, right? If you have an AI that say help you optimize something and it's actually not very good at it, right? It's like then you're not being responsible for the user. Why would they actually use you? Why would the user choose this AI tool, right? You're supposed to be, so for example, pros produce a lot of pricing algorithms that help pricing analysts optimize the pricing strategy to achieve a certain revenue goal, right? So it had to be good at what it's doing, right? If it's not good, then you're not being responsible for the user, for these pricing analysts, because they're putting their job on the roll, right? To trusting this AI to help them make the pricing decisions. So competency is really important. And again, many other framework may describe this as having statistical accurate, being reproducible, repeatable, right? Reliable, robust. All these probably mean the same thing. It just has to be good at what it's doing, right? So competency, right? But so beyond competency, it has to be what we call trustworthy, okay? Because if a user is not able to trust this AI algorithm, right, then they probably won't use it either, right? And because there's some having an algorithm that's a complete black box that the user cannot actually explain what it does, right? And what if some answer come out and some recommendation was made and the user adopted it and you actually didn't know why it came to that conclusion, and again they're putting their jobs on the roll to use this tools, right? So that's not being, I would say, responsible for the user either, right? So trustworthy, and there are many other, I would say, terminology that's used to describe trust, right? And AI that are trustworthy. Some of them are like they largely focus on transparency, right? Because people don't tend to not trust things that they don't understand. So if it's not transparent, completely a black box, right, then it's not good. But if it's transparent, it's explainable, it's understandable, intelligible. So all these kind of interpretable, right? Interpretability. So all these kind of folds into this trust category, right? Being able to trust by the user. And the last component in this layer, which being responsible user, is being empathic, right? You want to encourage the user and you want to empower them. You don't want to make them feel dumb or feel stupid. And so being responsive, being friendly, helpful, being engaging, right, and honest, right, all that will essentially drive the user make the user want to use these AI tools more, right? So that's being responsible to the user. So that's layer two, right? But once you pass this layer two, right, then you essentially pass what we call the adoption threshold, right? Between layer 2 and layer 3 is what we call this adoption threshold. Because once once the AI is actually competent, trustworthy, and empathic, it drives people's desire to use the tool, right? A lot of people will use it. A lot of people. So that's the adoption threshold. Before you actually achieve that, right? Adoption may still happen because some people they need to do it, they need to use it, or they may want to experiment with it, right? But it wouldn't be a mass adoption typically. But once you actually get through this layer 2, then likely you would have I would say reach the adoption threshold. The adoption will actually be depending on what the scope, right? Not every single AI tool is used by everybody in the world, right? So if you have a very specific industry AI tool, the people who's in those industry will have a mass adoption of that tool, right? Once you reach that adoption threshold. And
So for
then,
like enterprises, how do you balance the pressure for innovation speed with responsible development? Like, for example, there's a lot of folks that would vibe code with like an autonomous or
yeah.
like a what's it called, a what's that system called? It's called React. So it's like a reason and act code like loop where it just
Mhm.
thinks and it codes and then
Yeah.
brings in tools and continues coding by itself. And people have been able to build like entire applications overnight with it. There's like security vulnerabilities.
Yeah.
They expose like API keys to the
Mhm.
public, or they expose user data from their database to the public, but they're able to build it very fast.
Yeah.
So like how would you balance like innovation speed with being responsible when you're developing it?
Yeah, so that's why we have this layer approach, right? At the beginning, right, you should definitely use your AI. Like I said, the table stake is, yeah, safe, respect privacy, and obey the law, right? So all these are table stake, right? You have to have that, right, before, and then, and these are just three components, right? And then the next layer 2, responsible to user, competent, trustworthy, and empathic. So these are the next layer. And there's actually three more layer once you're past the adoption threshold, right? And the next level, the layer 3, is being responsible for the organization and the groups. Okay. And then layer 4 is beyond being responsible for the organization and group, you have to be responsible for society and humanity as well. Okay. And then the final kind of the layer 5 is essentially you also need to be responsible for the planet and our future as well. But once you pass this adoption threshold, you basically need to kind of understand what is the scope of application of your AI tool that you're building, right? Because maybe this tool is not intended to be used by everybody. It's only going to be used by a few hundred companies around the world who does a very specific thing, right? Yeah, then you probably don't need to worry about layer 4 and layer 5 that being responsible for humanity or being in the planet in the future. But you do need to worry about being responsible for the organization and the groups of people who are using it, right? And yeah, so yeah, and then like very quickly, layer 3, right, being responsible for the organization also has three components. That's fair, interoperable, and also being accountable. Because now you have a group of people using it, right? You don't when the AI make a decision, you want to be able to trace it and audit it, right, and all that right? And it's also have to be fair, right? To everybody who's using it. You want to be inclusive, you want to be unbiased, right? So all those, so again, I use fair because it's a simple term that encompasses a lot of other terms that other people use as well. So fair, interoperable, and accountable. So that's the other quality that you needed to being responsible for the organization and the groups of people, right? And then layer 4 essentially is that you have to be human-centric and respect human agency and align with human value, right? So that's how you achieve, right? If your AI is to be used by essentially have the global reach like ChatGPT, right? Then those are the components that you need to worry about. But if you're not at that level, you're not at that adoption level, right? Maybe you don't need to worry about that yet. So this is why I said this layer framework, it help you focus on what you need to focus on at the moment, right? When you get there, you need to focus on when you reach that adoption level or mass adoption level, the global level, right? Then you need to worry about these bigger layer 4 and layer 5, right? Yeah. So that's whereas if you're in academia, so each one of these layers essentially have, I think, three components, except the last layer. At the layer 5, which I haven't talked about, being responsible for the planet and our future, is that it has to be sustainable, right? And also have to be child safe, right? To be responsible for our future generation, we need to make this AI safe to use for our children today, right? There's a lot of people forget about this, right? So besides layer 5, all the other 4 layers have each one of them have only 3 components, right? So you only have to focus on 3 things, and that's very easy. Whereas in academia, they would say, oh, all these 14 different components, they're equally important. They all, if you try to make a company focus on 14 different things, yeah, that will make you slow you down. And that will actually, it is very, I would say, they are important, right? But you don't necessarily need to focus on all of them at once. So that's what the layer framework provides. Yeah.
Thanks, Michael, for coming on the show and telling us like all of your knowledge from your transition from like academia to industry. And for the viewers at home, stay curious.